Hello everyone, this is KP the Math G, and we are working with, believe it or not, we have released to us the free response questions from 2026, from the 2026 exam. And what we're looking at is the free response question number 5. This is AP Calculus AB, okay? So this is an AB question, and let's get right into it, okay? I'm going to make a confession. I said I did a video which I erased. I hated that because, see, one thing, my recorder can only record but just so long, and then it just shuts off. So I noticed that it had shut off, and so I had to, instead of trying to do both part C and D, I'm just going to do part C and then do part D on another video. So I've already been here, what, almost an hour? Not quite, but still quite a bit of time here. Yeah, I'm not dressed up. I'm in clothes that I'm going to go outside after a while and try to get some of this yard mowed up and everything. I'll do that after a while. It's kind of hot outside right now. Alright, so let's go ahead and look at this question. Let me go ahead and read it to you. A remote controlled toy car moves back and forth along a straight path so that its velocity at time t is given by the function v, where v at t is measured in feet per second and t is measured in seconds. And we're only going to do part C. In parts A and B, you had to use the derivative. In parts C and D, you're going to have to use the definite integral. And I'm going to show you when to use, or in this case here, when do I know to use a definite integral? Okay? Let me explain first of all before we go any further. A definite integral, let's say we're just making up some numbers, say from 0 to 2. This is in time. 0 to 2 minutes, 0 to 2 hours, 0 to 2 seconds, whatever. Okay? And in this case, we're dealing with a function of velocity. Usually we put dt at the end. We always do that. If you take the antiderivative, or in this case, the definite integral of velocity, so velocity is in feet per second. Notice that? So when you take the antiderivative, I say antiderivative, definite integral of velocity, you get something, you get distance. Distance in feet. Alright? So let's say you have something in, let's say, inches per minute. Okay? When you take that antiderivative, especially if it's velocity, you'll get just inches. Okay? Kind of like this in volume, cubic centimeters per second. It's going to be cubic centimeters. You're going to get just velocity, volume rather. Not volume with respect to time, but just volume. Okay? Amount, quantity. That's what you get when you deal with a definite integral. Always remember that. The only thing is now, you still get a rate of change if you're changing acceleration to velocity. Feet per second squared just becomes feet per second. You take that antiderivative again, I say definite integral, then you get back to distance. So you have distance, velocity, acceleration in these types of problems here. Here, we're going from velocity to distance. Alright, so let's read it and let's see if we can find, I'm just kind of giving you an overview of what, this is when you're going to use the definite interval. Because, I erased my problem. I erased my question. So let's write it down. It says find the distance. So find the distance in feet. And it's over this time period, so we're just going to just abbreviate this a little bit. So t is between 0 and 4. So I know that I'm going to go from 0 to 4. And look at this. I am finding the distance. So I know when I see distance in feet, I know my answer is going to be in feet. So I know that if I have velocity, it's going to be, velocity is in feet per second. So I'm just going to take the second off, and I'll just be in feet. Okay? So I'm finding the distance. I need a definite interval. I know to go from 0 to 4. Alright, I'm going to use red this time. 0 to 4. And since I'm looking at this from 0 to 4, I'm looking at this function here. So again, t to the 4th, t to the 4th, minus 8t to the 3rd, plus 16 t squared dt. That's, so I don't know if you get a point or not just for setting that up. I would have to say probably so. I don't know, but if they see that you set this up correctly, the integrand and so on, you've got this. 1 point for getting that. At least you got a point, didn't you? Now, how do we take this antiderivative, or how do we evaluate the definite interval? Alright, so let's take a look. Remember, on a definite interval, you are adding 1 to the exponent and you're dividing right there by that same number. You don't divide by 4, you divide by 5. Minus 8. Alright, so here we go again. T to the 4th over 4. Now 8 over 4 is 2. You can reduce that later. Keep going. Plus, don't forget your signs. Minus here, plus here. Alright, right down to 16 times t. You're going to add 1 to that. See there? Add 1 to that. 2 plus 1 is 3. Put that 3 underneath here. Now you are going from 0 to 4. Alright. You just move these over like this. And that's how you integrate something like that. Okay? Of that nature. Alright, so let's figure this out. Now, I'm going to show you how easy this is. Okay, so remember the fundamental theorem of the calculus. There's 2 parts to this. One of the rules is you start with that top one, plug it in. Okay, so 4 to the 5th, 4 to the 5th over 5. Okay, right? Minus 8 times 4 to the 4th over 4. And if you want to make that a 2 at this point, you can. So 8 over 4 is 2. Alright, you can do that. Alright, and then plus 16. Ooh. 16 t, which is 4 times 4 cubed over 3. Now remember, minus sign, always a minus sign in between. Now when you come into this zero down here, now minus. Now let's just see if we can evaluate this without plugging the 0 in. Let's do it mentally. What's 0 to the 5th? 0, right? 0 divided by 5 is 0. Alright, minus sign. 0 to the 4th is 0. 8 times 0 is 0. 0 divided by 4 is 0. Plus 16 times 0 cubed. What's 0 cubed? 0. 16 times 0 is 0. And 0 divided by 3 is 0. So really what I like to do, if I see a t in every one of these, and one of my, and that's a 0 right there, you can skip all of that and put one big gigantic 0 right here. 0. Minus 0. Well, now that equals 4 to the 5th over 5. And we'll put it in parentheses. Now don't multiply 2 times 4. Don't go back to your old ways. I mean, if you had these old ways, don't do that. Don't even try to figure this out. 2 times 4 to the 4th. Okay? Alright. And then my plus 16 times 4 to the 3rd over 3. Now, I'm just going to show you something. Why am I writing the word feet? I'm done. That's why. Because the rule is on the AP exam. I don't believe this rule has changed, even though I've been retired a few years. That once you plug the numbers in, like this, and you put the unit down at the end, so whatever this answer is, it's in feet. Now I went out on a limb and figured it out. 512 over 15 feet, which is 34 and 2/15 feet. That takes a little work to do all this. So why work all this out and take a risk on making a mistake and losing a point? You need all the points you can get, right? Don't go any further. You're done. Okay? Just write the word feet, and that's it. Now remember, when you take the antiderivative, or we might say the definite integral of velocity, in terms of feet per second, the seconds are gone, and you have a unit of feet. So don't put feet per second. That was velocity. So when you took that definite integral, now it became feet. You're down to units. How far? How far did you go? Well, this many feet. Okay, there it is. So that's distance. And the moment I saw distance, I said, aha, a definite integral, and I'm going from 0 to 4, so I'm using this function. Not this, not this. Now in part D, hint, we will use this one. And that takes a little explaining, which I should have known better than to try to do both C and D together. Alright? Well, you live and learn. Even when you're 65, you live and learn. Okay, so write your answer down. Don't forget to put your unit down. It is in feet. There it is. That's it. This dictated that we're using this function. And once you learn how to take the definite integral of that, it becomes easy. And you use the fundamental theorem of the calculus. Whether you call it part 1 or part 2 or part 2 and part 1, I don't know. It doesn't matter. But one of the two parts. Says you do the 4 first. We plugged in the 0, 0, 0, 0. Everything's 0. So we just wrote it out again and then put the feet on it. Okay, that's it. Well, anyway, KP the Math G is signing off. And if you've been with me before, you know what I'm about to do, a signature clap at the end. I don't know why. I just took that up and decided to go with it all the time. So anyway, I think it's pretty cool. Hey, anyway, if you want to, you can hit that like button, put a smile on my face. If you want to, you can make a comment. Okay, make a comment if you want to. And if you want to, hit that subscribe button. Okay, so I kind of like the more subscribers, but then again, if you don't, all you're wanting is to get the answer or trying to figure out how to do this kind of problem, okay, it's fine with me. It's not about me, it's about you. And so that's all I care about, is that you get this. But then again, if you subscribe, if you hit the like button, you make a comment, whatever, I like that too. Alright, anyway, good problem. In my next video, we will do part D. Okay, takes a little while. It's going to take a little while to explain this one. All right, KP the Math G is signing off. Ladies and gentlemen, have a great day.